Hi everyone, welcome to this lesson 2 of Explore ML's session and in the beginner track, powered by Google AI and Developer Student Clubs. I'm Ayush Sharma, lead at Developer Student Clubs, and presenting you with the Explore ML session. So in the previous session, we learned about the basics of machine learning, for high-level overview of machine learning algorithms, classification, regression, sequence prediction, and etc. And in this lecture, we'll be taking the high-level overview of the neural networks. Well, we'll start in a few seconds just after giving some like basic rules and introduction to this stuff. So I'll be sharing the link to the RSVP form in which you will put up your entry passcode at any random time in between of the session. That session will be of 30 minutes. We will try to cover all the stuff in 30 minutes. So just make sure you have a notebook to make the notes. And this is it. I guess we should wait for 2 more minutes so that more people can come and join us. Just for 2 minutes. I guess everyone has joined. I welcome everyone on the behalf of Developer Student Clubs, Google AI, and Google Developers. I'm Ayush Sharma, and we are starting the Explore ML's beginner track session 2, which is the basics of neural networks and the fundamentals of neural networks. So let me tell you rules again. You will get the RSVP form in between at any random time, and it will be open just for 5 minutes, no more extensions. So make sure you fill the RSVP form within that time, and we will give the break of 5 minutes, and we will try to cover the whole session in 30 minutes, not more than that. We will try to cover that. If that exceeds, we will try to wrap up all the things within the time so that we won't waste your time. Okay, so neural networks. If you have read about machine learning, you may have came across the term neural network. This is a very popular terminology going around nowadays. They are a popular choice for machine learning models because of their ability to handle complex data and make accurate prediction where simpler models might fall short. So sometimes neural networks are used because we can do complex mathematical problem solving with the help of neural networks, which traditional classical machine learning algorithms might fall short to do it. So let's know more about neural networks from this video.
Hi, I'm Nat.
And I'm Lo. And this is our 20% project, where we go find out about different Google stuff we're curious about.
Last year, we got to make a documentary about how voice search works. And that was the first time we heard about something called machine learning.
Since then, we've been kind of fascinated by it.
So today we're talking with Greg and Chris to learn more about it. How would you describe machine learning to someone?
Well, there's a lot of problems that's really easy to solve with computers. Computers can go and simulate how galaxies move and how the courses of asteroids going and how close they're going to come to Earth. I could never hope to go and do that, but I can go and do this problem like recognizing that that's a tree, which is so much tremendously more difficult for a computer.
It doesn't feel like intelligence to us because it's so effortless as a human being to do it, but for a computer it's actually really hard.
Because the real world is kind of messy and unpredictable at times. The strict logical rules that go into traditional programming just don't work.
Instead of going and writing programs that solve the problem, we write programs that learn to solve the problem from examples.
And it's this process of learning that allows them to improve over time and to actually be more clever than they would be if we wrote down a very rigid set of instructions for them to follow.
Machine learning is in so many different things that we use today that it's kind of like this invisible magic ingredient.
Phones with the ability to understand human speech.
Machine translation, email spam filters.
When you go to the ATM and you give a check and it can read the handwriting.
Or a Photos app that can automatically organize your photos based on the things that you like to take photos of. Like, here are all my mountain photos, here are all my food photos.
Here are all my dog photos.
Here are all my feet photos.
Everything from facial recognition to going and trying to recognize whether a particle is present in a particular collision at the LHC.
Which we just like to take a time out to say is that big tube in the ground over in Europe that smashes particles together at really fast speeds so that scientists can use that information to unlock the mysteries of the universe, among other cool things. Now back to our episode, because I am getting really dizzy doing this. Ooh.
So researchers and scientists are still experimenting and trying to find the best ways to teach computers how to learn. But a lot of the progress is coming from these algorithms that are based roughly on how the human brain works, and these are called artificial neural networks.
So an artificial neural network is something that it's a rough mathematical cartoon of how a biological neural network works. In a biological brain, we have individual cells called neurons. Each neuron looks at what its neighbors has to say and then decide what it wants to say. And in artificial neural networks, we have little mathematical functions. We put them in some organized structure, and then we say, okay, you guys all together, learn to do this task.
We have lots of neural nets that are really great at going and recognizing, this is a cat, this is a dog, this is a frog, this is a mouse, this is a horse, this is a truck, and things like that.
So take, for example, trying to recognize what this is.
So it used to be that we were really proud if we could get a neural net with 3 layers to work. And it's recently that we've made a lot of progress on techniques that allow us to train much deeper neural nets.
And that's why this kind of machine learning is also called deep learning. A neuron in the bottom layer is just going to be looking at a tiny piece of the picture and making some computations about it. It doesn't understand anything about dogs specifically.
But what the neuron does understand is it says, I'm giving a signal that's useful for somebody who's giving a signal, who's giving a signal, who's giving a signal, who's giving a signal.
They're kind of able to unfurl this really high-dimensional knot and pull it apart and make it easier to go and separate different things that are close together on the surface from things that were tangled all together earlier.
But then at the top, we'll put 2 neurons, and these neurons look at the whole picture so far.
They're basically experts at making the final call, figuring out, oh, all the layers below me said these things, so I know that this is a dog, or at least I'm 92.4% sure that it's a dog, so it's basically a dog.
And while there's been a whole lot of progress with teaching computers to learn, they're still much slower learners than we are, and they make mistakes that you and I wouldn't.
So what I was working on is sort of trying to find a way to go and look at a neural net and ask, what does the neural net think the platonic ideal of a cat is, or the platonic ideal of a dog, or anything it can classify as? And suddenly you can go and ask, neural net, what do you think a cat looks like? And you get a picture of a cat. Or, neural net, what do you think a barbell looks like? these weights. And it goes and it shows you a picture not only of a barbell, but of an arm attached to a barbell. So the model thought that the arms, it only learned what barbells were from looking at pictures of barbells, and they're often held by muscular weightlifters. And so it learned that there was, barbells have arms attached to them.
It takes them a long time to learn. You show it a picture of a school bus when it's early in learning. The very next time you show it a picture of a school bus, it's only a little bit more likely to say school bus. It doesn't get it, even though that was the very last thing it saw. Whereas, you say to a kid, that's a filing cabinet. And then a second later you say, what's that? Yeah. He's not going to be like, shoe, right?
Well, like, the more you describe this, the more I'm amazed by human beings.
Yeah.
The effect is like, wow, human beings are really amazing.
We're really amazing learning machines.
So guys, I guess you got a real great overview of what a neural network is. Okay, so in this video, I've got a few questions that might help in getting some of the concepts clear. So what is your definition of a neural network? You can use the chat box to tell the answer. What is your definition of a neural network that you've learned from this video or by seeing this video? 20 seconds. Anyone? Well, I'll tell you what it is. If not, so another question arises: what can a neural network do? Well, here in this video, you saw neural network can be used to classify images, identify objects, recognize speech. Yeah, I've got an answer. Learning through neurons, basically learning about our environment. Awesome. Great. I'm getting responses. That's cool. So you see, you can make a definition of neural network. Okay. A large collection of weights and biases which can be altered for special purposes. Nice. Running through various layers of data provided. And here I got an answer copied from Google, I guess. I don't care about it. So you've got an idea what a neural network is. I will tell you in a simpler language in the next slide. Another question: what interests you and what surprised you about this? So what was interesting or surprising in this video? You saw anything that's a little surprising? Anything that surprised you from this video, like anything new, anything interesting you saw? This is how research is in Google ecosystem occurs. This is the private video from Google research ecosystem. It is a learning in less grades, and that's interesting. What questions do you have about this? Identifying signs which are not clear. Interesting. What questions do you think you have in your mind after seeing this video? Well, I'm trying to make this conversation more and more interactive so that you can also learn more effectively. That's how they're designed. We'll come to that. Well, this is a high-level overview of a neural network. Well, let me show you what a real neural network looks like. So this is how a real neural network looks like on a paper, but you cannot see a neural network on like processing overview, but we'll look forward to see that. So neural network basically derives from the biological neuron. Let's learn some biology. I guess you are familiar with this image of a neuron in our brain. You might have learned this in class 9th or 10th, I guess. So I guess you can see the markings over here. This image is real bad. So Let me know if you can see the markings, what is written over here, over here, over here, and this. I guess you can see. So this is in biology. I'm teaching biology now. I'm sorry about this. We are not supposed to do that, but still, it's the part of curriculum. Okay, so this is the input part of the biological neuron called the dendrites. So here, the input is inserted from another neuron. This is connected like in a series. So we pass the neuron, the brain pass the inputs over here. This is the nucleus of a neuron. This is the axon, and I'll tell you how this is related to the artificial neural network. And this is the output called the synapse, but it is not written over here. It's quite quite deep diagram. So in this neural network, this works by comparing it to the biological neural network. This is the input over here, and let me first tell you what a neural network really is, and then we'll compare. So in short, it is just a mathematical function that maps a given input to a desired output. So whatever input we give, it passes through a mathematical function, and then it will provide the output. Got it? I guess you got. So in the introductory module, you learned about couple types of machine learning models, such as classification model, regression model, etc. Simple models works fine with simple data, but as soon as you want to interpret complex data like an image, any voice, any audio, or any video, you might require something called the neural network, because simpler models fails at this point. Simpler machine learning model. So it is the advanced machine learning model called the neural network, by which we can interpret images, videos, and audios, and any data which have large number of variables. For example, housing prices might have a large number of variables or features called might be location, number of bedrooms, sizes, etc. So you need something that is capable of doing this complexity or solving this complexity. So we have the neural network over here. These simpler models are connected into layers. So in basically in a neural network, simpler models are connected in layers. So this is an overview of neural network. This is called the input layer here, which takes the input. This is called the output layer, which gives the output. Got it? And all the layers between the input layer and the output layer are called the hidden layers of a neural network. So as soon as we have more number of hidden layers, the neural network get its depth. So here the deep learnings come from the depth of the neural network. So the name came from the name of depth of the neural network, deep learning. In reality, a neural network is a big complex mathematical function which looks nothing like but what you see here. In the diagram, you may see what's going on. It takes a cat as an input, and the neural network identifies that it is a cat. It's not a working model, it's just a diagram, so don't take it seriously. But in reality, it works like that only. Like any other machine learning system, model is trained with data fed into the model, and it attempts to make prediction. So any classical model takes the data and it attempts to make a prediction. At first, the prediction might not be right, or it might give out the garbage value, but we will use that output to improve our model. So we will take that output, whether it is right or wrong, we will try to improve the model's accuracy and try to find out the correct prediction. Once the prediction quality is sufficient, the model is tested with new data, and it makes a prediction based on what it learned from the trained data. So whether we got the right output or wrong output, we will try to take that as a feedback, and we will try to improve the model's accuracy and model's prediction. Okay, so what this diagram doesn't show is how each neuron is able to learn and improve based on feedback. So this diagram is not divided into neurons. So it's just a high level diagram. So let's look at the more deeply into what a neuron looks like. Okay, so before that, let me compare with this and this. So this is the main diagram of neural network with neurons. So this single body is called a neuron, which takes the input and has a mathematical function and gives the output. Again, the neuron takes the input in the mathematical function and gives the output. Again, this is also neuron. It takes the input, process the mathematical function, and gives the output. This is also neuron. It takes the input, process the data, and gives the required output. So this is input layer, and this is output layer. What are these layer called? Can I get the answer in chat? What are the layers in between of input layer and output layer? Anyone know? Anyone? 10 seconds. Come on. Great. I got an answer. It's called the hidden layers. So this is where the deep learning comes from. The depth, the more the layers, the deeper the neural network. So just like this, the neurons are connected one by one. So this is one neuron, and this is one neuron. In biology, it's look like this, and in artificial neural network, it looks like this. So let's get back to the presentation. So here is the inside view of a neuron, of a single neuron, perception of artificial neuron. So it takes the input, it activates. There's a new terminology called the activation function. I will tell you what this is, and yeah, I will tell you right now. So apply an activation function to a neuron. This is a mathematical way of setting the threshold or condition for activating a neuron. So for activating a neuron or for giving the output as required or not required, we will use a mathematical function called the activation function. This function is just like an if and else statement. I guess in programming you might have learned about if else. Yeah, you might have. So if something is greater than any value, we will. If something is greater than any value, if it is true, then we will activate the neuron. If not, we do not activate the neuron, and we will use that as a feedback in the input. So activation function is a mathematical function. So suppose we are trying to, let's take an example of if time is greater than 11 a.m., it's time to eat lunch. If not, it's not the time to eat lunch. This is the example I can think of. Excuse me. So it's just like a simple if and else statement. We set a threshold in this activation function. And if something is greater than that threshold, we will activate the neuron. If not, we do not activate it. The neuron checks to see if the input value meets the activation function's requirement. If it does not, it do not activate the neuron. The operation is carried out across all the nodes in the neural network. So let me tell you what a node is. So this is one node. We call it as a neuron. So this is one node. The collection of nodes or neurons is called the layer of a neural network. So the operation is carried out across all the nodes in the network, allowing very concept patterns to be learned and prediction to be made. So I guess you've got it. What do you think? You have any questions about it? Oh, time is running. I guess we would not finish it in 30 minutes, but still, we are going ahead. So let's take another example. Suppose we have number 5 as an input. If it is less than 10, we will activate the neuron. I see many of just copy and paste answer. Great. So let's take another example of 5 as an input. If 5 is less than 10, yes, it is. We will activate the neuron. If it is not, then we do not activate the neuron. So it is less than the threshold value, so we are activating the neuron. Here, activating means we are getting the right output from the neuron. So we got an handwritten image. This is another example. We got a handwritten image of number 7. So we see if it has a curve, like 6 has a curve, then we do not activate the neuron. So if it has a curve, we activate the neuron. If it does not have the curve, we do not activate the neuron. Okay. So here 6 has a curve, so we activate the neuron. So activation here simply means we are just giving the right output. Simple functions like this can combine to make more complex decisions. So this is just a simple function, has a curve. This is a function. If this passes the function, we activate the neuron. For example, the ability of this neuron to determine whether or not the input has a curve due to other neurons, checking to see if example has a pixel black or white. So basically this function checks if the curve has if the pixel is white or black at the curve points. So this is an example. So talking about the activation functions. So mostly the most common functions are sigmoid and ReLU. So sigmoid is quite old. Researchers describe the field of machine learning less like engineering and more like scientific exploration. For example, for a long time, sigmoid function was used until ReLU function was discovered to be more efficient and effective for many situations. It's not necessary to know all of the mathematics behind machine learning in order to use it, but it's shown here to reinforce the concept of machine learning is at its core a complex mathematical function that is trained to do well on a particular code. So sigmoid, let me talk about sigmoid. It's a binary function that converts a weighted sum to a value of 0 or 1. So it's basically used for classification in a neural network. So whatever in here input is x and output is f of x. So this is the mathematical function. I guess in 11th to 12th standard you might have learned this in the derivatives or differential integral chapter if you are from mathematical background. So x is taken as an input, and we will process this 1 upon 1 plus e exponential to the power of minus x. So whatever input we give, if the value is above the threshold, we will consider it as 1. If it is below the threshold, we will consider it as 0. Okay, so here we are setting a threshold of 0.5. Okay, so this is just an example. It can be anything. The threshold can be anything. Threshold is any limit we set, is the midpoint we set. If it is above that, we will consider it as 1. So let's take an example. There's a very common example of breast cancer classification. In that, we take the data and try to find out whether a patient has a malignant breast cancer or benign breast cancer. So there are two categories: malignant and benign. So benign is for like long term, and malignant is terminology for short term breast cancer. So if a person, if there are some features which are given as input, and we calculate the sigmoid activation function, if the output is greater than some threshold, above the threshold, then we will consider it as benign. If it is less than threshold, then we will consider it as malignant. I hope you understand from the example. What do you think? What questions do you have about this, about the sigmoid function? Five seconds. No questions. That's great. Okay, so another function comes the ReLU function, or rectified linear unit. So it is a way more smoother function. It is quite new and quite efficient function. If we talk about the activation functions, there are lots of activation functions like TNH function and lots, etc. Okay, you call the name. Yeah. So in rectified linear unit, okay, I got a question. It is a type of basic rule-based programming. How can you say it is analog? Well, it is that's a very good question. So in this is just inside of a single neuron. So by collecting number of these functions, like as I've shown you in this picture, So this is a part of just a single neuron. So if we want to process way more complex problems, we try to merge all these neurons in a layer, and these layers are then connected to another other layer which contains the same function or different function. Then we can say it's just used for way more complex problems, not as a rule-based problems. So in ReLU, what we do, uh, we try to neglect the negative values. Okay, so whenever we give the input as a negative value, like um, any negative value below the less than zero, then it will definitely, or it will automatically convert that to zero. And if you got any positive value, that would be the output. So this is about value function. For more, you can go ahead and check the online tutorials by Google developers and Google AI on YouTube and their official website that I'll be telling you in the next slide. So basically, here's what a perception of a neural network looks like. So whenever we give an image as an input, it will distribute each features or kind of each part of the image, not each part, each part of the image, and it divides the image and sends as into the activation function, and then that activation function calculates the do the process of the data and gives the output. Then it will also take into another activation function, and that gives the output. So these are high level overview of what's in a hidden layer, how the process works. So neural network can be comprised of many hidden layers. There are intermediate steps to get from the prediction to the output. For example, a neural network may have layers to detect certain colors. These layers maybe they're available to detect some colors. These to detect some features like long nose, black eyes, or irregular facial shapes or anything. So these are to detect some other features and might be used to detect some other features. So it is important to clarify the neural network does not know what a dog or cat is. It's just learning to do what we want to do based on feedbacks and patterns it detects. But how does a neural network learn from feedback? Neural network were loosely modeled after the biological brain, as I've already told you. The connection between the neurons can be strengthened and weakened using weights and biases. So there's the new terminology comes weights and biases. I will tell you what these are. For example, when a dog receives a treat and a pat on the head for retrieving a ball, it is more likely to do again. So while training a dog, when we give something, when we give a reward to do some certain task, it learns, it try to do that again and again, or try to learn from that and do that task more better. So weights and biases allows a neural network to learn what pathways work for a certain task, and bias the network to use the pathways again. This makes the neural network more effective and efficient at making the prediction. All of these complex calculations are accomplished far more quickly and often than a human could ever hope to do. It requires a lot of computing power to achieve high quality results, which is why neural networks were once thought infeasible, but now data centers, also known as computing clouds, with greater computing processes power, make neural network a reality. So in the last lecture I've told in the history of neural networks, it was not feasible to perform machine learning because of lack of high computing power, but now it is quite possible because we got so many free resources on the cloud and way more high computing power. So let me introduce you to a new thing called the TensorFlow Playground. It is an experiment by Google AI. So in the TensorFlow Playground, machine learning is typically implemented using programming languages like Python and R, but here we do not require to to perform machine learning using any programming languages. For those who do not yet write code, there are APIs offered to make machine learning option. But in this session, we are going to use TensorFlow Playground, a tool for exploring and learning about neural machine learning without the need to write code. So you do not require to write code. We will showcase how does machine learning, what's inside a neural network using TensorFlow Playground. So here it is the output. I have a question. Can you separate the blue dots and orange dots by using a single straight line? Is there any way you can separate blue dots and orange dots using a single straight line? Well, yeah, definitely not. You would require, what would you require to separate these dots? So what would you use if you do not have a straight line? What would you use to separate these? Using circle? Oh, yeah, circle might be an answer. Yeah, circle is the answer. A circle which can be made by combining a bunch of lines and functions. It may be helpful if you draw a circle to separate these dots. So yeah, so neural network can be built to solve these complex nonlinear problems too. So this is a quite complex nonlinear problem. While you can see the output on 2D graph, the effectiveness of the model is measured with a loss. You see the loss. So the loss is nothing but the difference between your model's prediction and the data. In general, the lower the loss, the better the model will be. Okay, so our main goal is to lower the loss so that we can get more accurate answer. So these are the input. We call it as features. So what properties do you want to feed into the neurons or in the mathematical function so that you get the required circle as an output? Okay. So on your left, you can see features. In the TensorFlow Playground, these are simply mathematical functions like a vertical or horizontal lines and their combination. So vertical lines, horizontal lines, and combination of these. Real world examples might include dog versus cat. So these features can be changed from mathematical to in real world. We can take these features as size, color, length of tail. Classifying numbers can be an example for that. So we can take the features as number of curves, number of lines. There are lots of examples. Let me give another example. Let me think of it. Yeah, predicting the housing prices based on location and other properties. So these features can be location, number of bedrooms, size of the property, etc. Nearest gas station, way more, a lot of features. So these are called the hidden layers. So we can, using this plus and minus sign, we can increase or decrease the number of hidden layers based on our required output. So this is where the complex pattern in the data are discovered. So the neurons try the data, the complex patterns in the data is identified over there here only. Permutation of the features, feature data is tested on how well it separates the data. So the outcome is graded. This is known as loss. This is used as feedback to improve the model. There are some rules of thumb for crafting neural networks, but it's not likely I could tell you before what right answer is. A high quality neural network takes experimentation and iteration. So it's not just if we give input, it runs just by once and it gives output. We need to run it again and again. We set an epoch value so that we can run it. We give the feedback again, then it learns from the feedback and it gives the required output. So here is the link. I will I will give that in. So go ahead, use the link, try to do the 3 exercises. In the first exercise, in the first neural network, you will have to, the instructions are given over there. You need to separate these using these nodes and input features and number of hidden layers, and try to lower the loss and get the better prediction. So I guess it's time to give out the form for RSVP so that you can put up uh, your unique entry passes. So here's the link. Go ahead, fill up the form. You've got 3 minutes to fill up. I'll close the form at 3:44. Make sure you fill up the form within the time. So till then, we're taking a short break. You can check out the link I've shared, and you can fill up the form right now. So I guess you've filled the form. Let's skip 2 minute time window. It's open for 2 more minutes. If you haven't, do it right now. Otherwise, we will not give you the information how to get the certificate. Okay, so the link I've shared, make sure you copy it and make sure you keep the back of that link. Perform all three tasks of neural networks. So if we were physically present over there, we would have done that in the classroom, but we do not have enough time to do that. And so you have the link, you can do the task. If you have any problem, you can just ask the team. So let me tell you one great thing: the teachable machine learning. This is the limit of machine neural networks. So in this experiment, we are going to use teachable machine learning, teachable machine, another online tool for machine learning. Teachable machine is powered by mobile net, a neural network optimized for size, so it can run on your mobile phone. So if you have got phones near you, you can just go ahead and type in this URL in your Google Chrome browser or any browser. Google Chrome is recommended. So go ahead and type in this URL g.co/. So we broke down the URL teachable machine. Okay, so let me open that. So you will see the version 2 of the teachable machine. You can go ahead and search for version 1 and try that too. So URL is just v1. So have you open it? So make sure you use /v1 after the URL that you have posted. Sure, I'll do that. Click on Let's Go.
This is an experiment that lets you explore how machine learning works. You can teach the machine using your camera and make it respond to you in fun ways. Okay, over here is your input. You should see yourself. Over here are 3 classes: green, purple, and orange. And over here is the output where the machine responds. Right now it's set to respond with one of these 3 GIFs, but you can also make it respond with sounds or speech. Okay, so first we're going to teach it to respond with the cat GIF when you do something. So do something like put up your hand, kind of like this, and hold this green button for a couple seconds.
Well, you can do that. I cannot. You can do that on your phones. It is like accessible in phone too. So what you have to do, you have to just do something like waving the hand and hold up the green button so that it will take the data of waving the hand and it will get the output of this. Then do something else like stretching your face and hold the purple button, and you will train the data for like until it gets 100% confidence, and then it will predict the output. Let me find if there is any video of that. Yes, there it is.
Hi, I'm Lasse. Hi, I'm Andreas. This is an experiment called Teachable Machine. It makes it easier for anyone to start exploring how machine learning works, live in the browser, no coding required.
Over here is the input, my camera. And here are the 3 classes, green, purple, and orange. And over here is the output. This is where the machine responds to you. Right now it's set to respond with one of these 3 GIFs. You can change these GIFs to any GIFs you want. First, I'm going to teach the green class to recognize when I put my hand up, like this, and show a cat GIF. I just hold down the green button for a couple of seconds. So now it's training the green class, and there. Now you see that the green bar is up with high confidence and it's showing the cat gif. But you'll notice that the green bar is up no matter what I do, if the hand is up or down. That's because the machine is looking at my input and deciding which class it's most similar to. But since I've only trained one class, everything looks most similar to that one. That's why I need to teach it a second class. So now, with my hand down, I'll hold this purple button for a couple of seconds. And it's training the purple class, and there. Now it's working. When I put my hand up, the green class triggers with the cat gif. And when I put my hand down, the purple class triggers with the dog gif. Up, down, up, and down. What if I raise my hand just a little bit? It's kind of confused. The bars are wriggling around because it's not sure. Is it the green class or the purple class? If I raise my right hand instead, you'll see that the machine still recognizes that this is the most similar to the green class, which is kind of interesting. Let me try to train this orange class with a crazy face, like this. So now when I make that face, it should trigger the last bunny gif. It works. And I can also switch it to speech. Now when my hand is up, it says hello.
Hello.
And when my hand is down, it says awesome.
Awesome.
And I can change these to anything, like, oh cool.
Hello. Oh, cool.
The point of all this is to let you start digging into machine learning in a hands-on way. Like sometimes your machine might not work. You can learn a lot by thinking about your examples and try different approaches. You can even try to confuse it on purpose, which can be a really fun way to learn. It's built with a library called deeplearn.js. This lets you train and run machine learning models locally in the browser, which is what makes it respond so fast. And deeplearn.js works on mobile devices too, so you can try this experiment with the camera on your phone. You can get the code and start teaching your machine at g.co/teachable machine.
So you see, this is how the teachable machine learning works, or teachable machine. So there's also version 1 of this. So it's quite interesting. Like, I love this name. So if you want to see this video, I've provided you a link. We do not have enough time. There's the link to the version 2, and it's way more interesting than the previous version. So guess play it for a few minutes, and can you confuse the machine? Check out by yourself. I'm still repeating, if you are in the physical class, this would be way more fun than this online session, but due to some circumstances and lack of venue, we are not able to do that. So let's review what we have learned till now. What is a neural network? In simple language, a mathematical function that maps through the data to process the output. When it is useful to work on complex data like images, audios, and data with lots of features and variables. What it can do, what can it do that a simpler model might not be able to do? I've already told you what is the limitation of machine learning, or neural networks in general, or machine learning in general. I'm sorry about that. So you see the teachable machine, an experiment by Google AI. So I guess this is it. This is for today's session. We are about to complete it, and we are at the end. Make sure you have filled the required form that we want you to fill in the comment section. Use the links to learn from the resources. The links for Teachable Machine is in the chat box, and the link to developers at google.com, which have the TensorFlow Playground, which have 3 exercises, are in the chat box. So you can play with those 2 things, and you can just perform the neural network. So next up, let me tell you a few things about how to get the certificate. If you have got a unique code that you have provided in the forms yesterday, day before yesterday and today, we will tally them. And if you have attended both the sessions, if you have got the entry in a form, Then we will send out the data to Google developers, and it might take some time to get the certificate of the beginner track because it's a program that is run in whole India by Google AI and all developer student clubs. So don't worry about the certificate. If you follow our instructions, you will definitely get the certificate. So we will send if you have filled all three forms, and we will send the feedback form. If you have filled those forms, we will collect all the data and we will send out to Google developers, and there will be no problem in getting the certificate. So make sure you bear with us. Do follow our social medias at the DSC RJIT. Let me show you. So this is our Instagram page. You can search for instagram.com/DSCRJIT. So let me provide you with the link for this is the Facebook page, Developer Student Clubs powered by Google developers. You can follow us on Twitter, also on LinkedIn. Wait. So make sure you follow us on all social medias. Also subscribe our channel to get more videos and updates. We are trying to we are planning for some playlist of programming languages like Python and other. So you can just go ahead and subscribe us and like the live stream if you like and subscribe the video, and do follow us. So let me give you the link to, yeah, I know it's down. We are working on that. You can use this link as a alternative. So this session will not be accessible after this live stream, the video, because of some community guidelines that some restrictions that we have provided. So, and one more thing, each and everything we do in DSC or developer student clubs is free of cost. We do not charge any money from anyone. So if anyone asks you for the money in the name of DSC RJIT, please don't go near them, or please report to us for them, because we are free of cost. This is a community work. And one more thing, if you want to support our community, you can also come up as a speaker. You can also come up as a speaker in our events. So this is the first live stream of developer student clubs. Next up, we are mostly thinking of doing physical meetups, and you can also become the speaker. Just send us the proposal, as I've said in the last time. So you can just see the events. We have a planned event of Flutter Interact viewing party at 19 January in Gwalior. So if you live in Gwalior, you're welcome to register to join us. This is a community work. You can also collaborate with us. And apart from DSC, we are also the community leads of Crowdsource, DeepLearning.ai, and Kaggle Days. So you can join those. And also we've got sponsors like Hyperledger, that is a blockchain technology. We have got them as a sponsor. We have sponsored Google developers and Google Cloud, Google AI. Mostly we are powered by Google, so this is not any chance of speaking. We are also sponsored by Sorted Square for Flutter Interact viewing party. So make sure you join us in our next event. Ayush Sharma taking your leave. Goodbye.